Why the data path has a huge impact on the performance of the CPU. What's a data path cycle? The data path cycle, also known as the pipeline cycle, is the time it takes for an instruction to move through the data path from the instruction fetch IF stage to the write back WB stage. In other words, it's the time required for an instruction to complete one pass through the pipeline. The data path cycle is typically measured in clock cycles, and it's a critical factor in determining the performance of a CPU. The data path cycle, also known as the pipeline cycle, has a huge impact on the performance of the CPU because it determines how quickly instructions can be executed. Think of it like an assembly line. Each stage of the pipeline, instruction fetch, decode, executes, memory access, etc., is like a workstation that performs a specific task. If one workstation is slower than the others, it creates a bottleneck that slows down the entire assembly line. In a CPU, the data path cycle is the time it takes for an instruction to move through the pipeline. A shorter data path cycle means that instructions can be executed more quickly, resulting in higher CPU performance. Okay. Factors that affect data path cycle. Clock speed. The clock speed of a CPU determines how many instructions can be executed per second. Higher clock speed means that instructions can be executed more quickly, reducing the data path cycle. Pipeline depth. The pipeline depth refers to the number of stages that an instruction must pass through before being executed. A deeper pipeline can increase the data path cycle, as instructions have to pass through more stages before being executed. Instruction level parallelism, ILP. ILP refers to the ability of a CPU to execute multiple instructions simultaneously. This can reduce the data path cycle, as multiple instructions can be processed in parallel. Cache performance. Cache performance refers to how quickly a CPU can access data from its cache memory. Cache misses can lead to longer memory access times, increasing the data path cycle. Understanding these factors can help in designing more efficient data paths and improve the overall performance of a CPU.